Hello everyone. Welcome to the first lecture of module number 4. Yeah. Module number 4 consists of a measurement of some quantities and the uh, apparatus used for that. So here we will study about the measurement of strain, measurement of force, measurement of torque, then measurement of temperature, etc. So such parameters, how they are measured, what is a parameter, how it is varied, then the units of that, then how they are measured. Okay, such things are deal in this module. So in this lecture, we are studying about the measurement of strain. Now, when I say strain, you had already studied in mechanics of solids that strain strain is nothing but a relative quantity of a change in dimension to the total dimension of a deformable body. Now, why strain is to be measured? Why we need to measure the strain? The intention is simple. We are measuring strain so that we can analyze the stress. So this is an indirect approach to measure stress in experimentally. Okay. Because strain is nothing but stress and strain are proportional according to Hooke's law. Okay. So according to Hooke's law, stress is proportional to strain in a limit called the elastic limit, and the ratio of stress to strain is called elastic constant. Elastic constant or elastic coefficient. You had already studied about this. So if you measure strain directly, which is a ratio of change in dimension to the original dimension, then multiplying that with the material properties like elastic constant, you can determine the stress. So this is an experimental approach to measure stress indirectly by measuring strain. And you know that strain is a non-dimensional quantity. Strain is a non-dimensional quantity. Why? Because strain is equal to change in length by original length, or there is a change in diameter by original diameter, or change in any dimension to the original value of the dimension. So this is a ratio of uh, uh, dimensions of distance. So it's a non-dimensional quantity. Okay, and usually they are represented in micrometer per meter scale. We have different types of gauges and sensors that can measure the strain, and the most common one is your strain gauge. Okay, and in this lecture we will be studying about the strain gauge. So before moving to that, let me say or tell you, you have to revise uh, these topics from your mechanics of solids. That what is stress, what is strain, what is Hooke's law. So revise these topics from your mechanics of solids. Hooke's law, then Poisson's ratio, okay, then lateral strain and longitudinal strain. So you have to revise from mechanics of solids. So revise the topics from mechanics of solids. The principle of strain gauge uh, is that when a material deforms, the electrical resistance will also change. So this is the basic principle of a strain gauge. That is, the electrical resistance of the material varies when it deforms. And the specialty is that the strain gauge is a passive transducer. We have already described this name of strain gauge as an example of passive transducer in module number 3. So passive transducer is nothing but a device which transfer one signal into another form without the aid of an external powering source. So this convert the mechanical displacement that is obtained due to deformation. The mechanical displacement, or so-called the deformation, into an electrical signal. And the principle is that the electrical resistance is directly proportional to the length and inversely proportional to and the area of cross section of the conductor. So here L is the length of the conductor, A is the cross sectional area, and rho is a resistivity. So the resistance of a conductor is directly proportional to its length and inversely proportional to the area. Now the classification of strain gauge, we can classify them basically as metallic one and semiconductor one. We will be focusing mostly on metallic ones. Now again, metallic strain gauges can be again classified as a bonded and unbonded ones. In bonded one, you have to study about wire bond strain gauge, metal foil strain gauge, and rosette strain gauge. Now, your electrical strain gauges. So, electrical strain gauge measure the change in the resistance, the capacitance, and inductance. Those are electrical properties. So, measure the change in this electrical property due to strain in your electrical component. The strain is got transferred from your workpiece, which is undergoing deflection. Now, based on the mountings means based on how it is placed. The strain gauges are classified as bonded strain gauge and unbonded strain gauge. The figure is given here. We will study them in depth in coming slides. Now, here is a bonded strain gauge. It is nothing but we have a strain gauge which is attached to the elastic surface which is undergoing deformation. Okay. So they are primarily used for strain analysis. Now here your bounded resistance wire, you have a resistance wire which is cemented or pasted to the base. The base will be a thin sheet of paper or a thin sheet of bakelite. So those are the materials used for making the base. So you have a wire frame which is attached or cemented to the base made of paper bakelite, or Teflon. Now the deflection in your base plate will be dictated by the wire by change in its resistance, and this signal is transferred to the processing unit by using Wheatstone bridge circuit. Now the Wheatstone bridge circuit convert these electrical signals and manipulate them to get the desired form of output. We have three type of bonded strain gauges. The first one is wire strain gauge, second one metallic foil strain gauge, and third one is rotor strain gauge. So this is a picture shows you have a base plate. This is your base plate, and this is your coil. You are cementing this coil or above the base plate. Now, the base plate will be subjected to force, and it will deform. And this deformation will be catched up by the foil, and there will be a change in its resistance. This resistance got transferred to the circuit using Wheatstone bridge circuit, and the Wheatstone bridge circuit convert this to subsequent voltage, okay, so that this can be manipulated or processed. Okay. In wire strain gauges, the resistance element will be in the form of a wire foil, which will be looped to and fro direction like this. It will be looped like this in to and fro direction, and the dimension of your wireframe will be around 0.025 millimeters. So it is such small in size, and it is placed like this. It is placed in a loop, to and fro loop. Okay. And the entire structure is cemented over your uh, base plate, which is subjected to member subjected to stress. So this is called the base plate. Now, when the base plate is subjected to external force, it will deform, and this deformation will leads to a change in resistance in your wire foil, and this resistance is transferred to the Wheatstone bridge circuit, where it is converted to an equivalent voltage, so that it can be processed later. Now, in your metal foil strain gauges, instead of your wire, you have a metal foil. This metal foil will be placed over your base plate. And the materials for metal foils are described here. And one of the properties that this exhibit a higher gauge factor than your wire strain gauge. Now, a gauge factor, it is a property which describes the quality of your strain gauge. We will study it on later slide. So, in your rosette strain gauge, this is completely different. This one is used to measure shear strain. The previous two strain gauges were used to measure normal strains. Now here, Rosette strain gauge is used to measure shear strain. So the property is that the shear strain will be acting parallel to strain axis. So they are used to measure shear strain. Now, if required, you can place it in more than one direction. So, and you can detect the strain in more than one directions. Like now, as I said, these wires will be it will be placed over, and it will be adhesed to or cemented to the base plate. Now, the adhesives used for this cementing are listed here. They can be epoxy or ceramic cement, sometimes cellulose nitrate, sometimes cyanona cerlate cement, or polymed adhesive or phenolic adhesives are used. So these names can be asked for 3 mark question. You can expect this for a 3 mark question. The question will be this: what are the adhesives used in bounded strain gauges? Now coming to unbounded strain gauges. So here it is completely different. Here the wireframe is not fixed to the member which is subjected to deformation. Instead, you have a separate movable arm which transfers the force or the deformation to the wireframe. So here you have 4 arms of your wireframe. Now when the force is acting at this movable arm, uh, this body will move, the unbound strain gauge wire will move, and the resistance in your wireframes will be marked, and that will be transmitted to the Wheatstone bridge. So here is the process. Okay. Now unbound strain gauge measure a very small motion of order of 50 microns and very small forces. So this is a specialty which increases the bandwidth of shear measurement. So now when it comes to an application where there is the shear stress will be in very much small ranges of micrometers or picometers, then these unbound strain gauges can be used. Now they are rarely used currently because it is very much complicated in design, and the bounding materials are well developed so that bounded strain gauges are enough to measure lower scale of strain gauges. Now the semiconductor strain gauge. The basic principle is piezoresistive effect. Now a change in value of resistance due to the change in resistivity of the semiconductor because of strain applied. So here you are using semiconductor materials of germanium or silicon. The advantages and disadvantages of semiconductor strain gauge are listed here. These questions will be listed on the advantage and disadvantage strain gauge, semiconductor strain gauge, or explain the principle of semiconductor strain gauge with a figure and list down the advantage and disadvantage. So each and every slide in this lecture is 3 or 4 mark question. Now, as I said earlier, here is the term called gauge factor, which is a parameter which describes the quality of your strain, or this describes the sensitivity of your strain gauge. There is nothing but it's a ratio between a relative change in resistance due to change in relative length. Means, as I said, your strain gauge will be subjected to deformation, and there will be as a result of that there will be a change in resistance. Now, since it is deforming, you can have relative uh, uh, change in your length, and since there as a result there is a change in resistance, you can have relative change in resistance. Now, the ratio of these two parameters, that is relative resistance to relative length, is called the gauge factor. Now, a strain gauge with a higher value of gauge factor is an improved one with higher sensitivity. So, the desirable characteristics of strain gauge is asked here. This is also a 3-mark question for you. It must have higher value of gauge factor. It should have high resistance. Uh, it must be resistant against temperature, because temperature losses must not be there. Now, the variation must be linear. Non-linearity does not has to be there, because we are expecting a linear variation of resistance with respect to the deformation. Now, the gauge wear should be low and stable resistivity, and also a low temperature coefficient. So, that's all about this lecture, module number 4. So this was the first lecture from module number 4. Now, the second and third lectures will be uploaded in 2 or 3 days. Thank you, everyone.